Today's episode is sponsored by Learning Blade. Middle school is the ideal time for career exploration. With Learning Blade, you can easily integrate STEM and career awareness concepts into your classroom. Find out if this resource is free in your state at learningblade.com. Thanks, Learning Blade. Hey, is this thing on? Are we recording? Can I get a tech person? Oh, for the love of ed tech. Joining me today is my co-host, Matt Gerbrick, who is my colleague, and he's back again for another rowdy rendition of the podcast.
Oh, yeah.
So
Let's
thanks,
do
Matt.
Let's do it.
And talking to us today is Tom Jenkins, who is an educator with 25 years of experience in the classroom at Greenon local schools, and who recently transitioned into an educational program manager position at the National Museum of the United States Air Force. So, hey, Tom, thanks for joining us.
Hey, thanks for having me on today. This is a wonderful podcast. I'm thankful to have the opportunity to be a guest.
Yeah, we're so
An
glad
honor to have you.
said yes. So just to kick us off, I guess, or start us out, can you just talk a little bit about how you ended up in education and what landed you, I guess, where you are now?
Sure. Yeah, oddly enough, I never thought I would become an educator. I was a student that managed to get by in school, but like many students that were in Title I schools, I didn't enjoy most of the STEM classes that I was in because we didn't have many labs or activities. It was only after I started coaching that I wanted to become a teacher because I was with a guy named Jeff Witt, who was my mentor, and I saw the way he coached with the kids, and he invited me into his classroom one day. And then when I saw the way he interacted with all the kids in the classroom, it really I went right away from being a political science major and switched to an education major, and that got me started at Springfield City Schools in a classroom teaching a wide variety of classes. After a couple years, I migrated out to Greenon Local Schools, which is Enon, Ohio, where for 25 years I taught science, technology, engineering, and mathematics as standalone classes, and then as a STEM course. And when I think teachers can often get frustrated with like people ask, like, how am I going to use this as a new concept in my life? I think it's a fair question because when I looked back, when I was a student, I hated geometry. It wasn't until I was in my 30s building a deck on my house, I saw the practical applications of what I spent a year learning when I was 16 years old. Kids deserve to know how and why and what they're learning to help them throughout their life. And if we as educators don't explain the why, then we miss an opportunity for engagement. So it was this kind of thinking and opportunities and a lot of support from my peers in administration at Greenon Local Schools to where I had an opportunity to become part of the Dayton Regional STEM Center 15 years ago that I was strongly encouraged to pursue this professional development. And as I got involved, we were doing all these wonderful activities. It was not only classroom teachers, but it was representatives from higher ed, it was private industry, it was the government, and we all worked together to create experiences for young people. And so when we were doing this, I was thinking to myself, why don't my kids at my school have this? So I started a program at Greenon that turned in from one class of fifth graders to now we're not even a STEM school, but Greenon has hundreds of kids from 7th grade through 12th taking a wide range of STEM courses. So I started doing things, and word got out, and before you know it, I'm at the National Museum of the United States Air Force, hoping to do similar things on a regional level.
I like your example with the deck, and I think that's what's missing for kids now is that application. The why does this matter? I mean, I think it always was missing when you and I and our generation, but we just did it, and because that's what you do. But there's so much more information and so many more opportunities out there that kids ask why. And as we look at some of the data about kids, their satisfaction or how often do you learn something new in school, and those numbers really have seemed to have trended downward over the last 20 years or so, especially since our phones and everything have been so ubiquitous that we've been able to just learn things when you want to learn them now. And so in school, being able to apply those things and here's why it matters and those hands-on activities that certainly STEM lends itself to and really is relying upon is a huge thing. And it's great that it's grown from what you started it at Greenon to what it is now there and many other places.
Yeah, 100%. Kids deserve to know why they're learning what they're using and how it'll help them. It used to be kind of a bad thing that kids would question, why am I learning this? When will I ever use this in my life? And like, I really think that we're failing them as educators if we can't articulate that message. And like, the kids' time's valuable just like anyone else. So like, it's up to us to make sure that we draw in these real world connections, these career possibilities, and we package them with the content we're learning, because I guarantee a lot of the students I've worked with over the course of my career, you know they want an opportunity to make money and earn a living, and because a lot of times they don't have financial stability at home. So if you want kids to buy in, and teachers are wondering, like, why are these kids not like so excited about this stuff, is because they don't understand the practical application and how it's going to help them throughout their life. I really think if we just spend a couple more minutes explaining how and why this is useful to them, then the kids will buy into it 100%.
Amen.
Yeah.
Amen. Preach.
I know. Well, and I know too, like, even as a teacher, I've struggled to like answer that question.
Uh,
I'm just thinking, like, I don't know when I have used this since whatever grade, until you're in those scenarios, just like you building a deck. Well, yeah, like I laid a floor.
right.
And then, yeah, and then you understand you're like the importance of knowing some of those skills, but sometimes there are concepts that you struggle to explain. And
For
then I
sure.
also think you have to ask yourself, well, then is it dire to their success in life?
Mhm. I
That's
find that
Yeah.
as a
really
parent
important.
too, where my
Right.
son's in seventh grade and he'll come home with some homework, and I'm like, I don't even know what this is, and like I can't even really. Sometimes, not all the time, but there's many times where I really can't even tell him why he needs to know it, because it's like I haven't seen this since 1984. Like I don't
Right.
know, I don't remember doing this, and if I did, I didn't use it. So, but I don't want to. You certainly don't want to have a negative. Give a negative vibe off about what schoolwork is, because I don't know what he'll end up doing. And
Sure.
so it
And
may be important to him. It just didn't factor into what I did.
Mhm.
But I think that being able to ask why and it be okay to do that's important.
And Matt, to your earlier point, students have so many ways to access information now. And so, like, I really believe that we need to emphasize the skills and the practices that go along with this. And it's kind of one of those things where content and standards are definitely important, and having an understanding of fundamental knowledge is essential. But, like, we need to spend more time with the kids being thoughtful about how this applies to their life, how they can use it, and having the tools in the access, and just kind of even the knowledge of the careers that exist, so they can contextualize all of this stuff and then have a reason for what they're doing. And I really think that, if I had my way, every teacher across America, for every lesson that they did, would not only make sure that kids are aware of the state standards and the objectives of the lessons, but they would also have career connections, because I just think it's in career connections are an integral part of the educational experience and getting these kids ready for a life after high school, regardless of what life that may be. Maybe it's a 4-year schools, maybe it's 8-year schools, maybe it's 2-year schools, maybe it's just tech school, maybe it's no school at all. And they just need to have skills that will help them earn a living and be a productive member of society.
It's almost like there ought to be life standards instead of academic content standards. Like there ought to be, another set of things that align your content or your curriculum with to engage these kids.
Well, yeah, and I really do think it's about making a whole, building a whole student, right? Helping them find out how all these things interconnect and how they can be useful to them. And, it's just another reason, and we'll talk about it here in a minute, about like convergent education, where rather than the subjects be standalone, the subjects need to be interwoven together. And you do have those skills and those practices interwoven with the content. And that just helps it stick a lot better, I think.
I think I have a binder somewhere from 1996 when I was teaching in Florida, and it was called Connections back then. I remember the eye rolls back then about cross curricular and doing exactly what you just said about, science and math, and we always marry those two together, but it could be science and English or social
Right.
studies and art.
Most
Doesn't
definitely.
have to be just those four cores, and especially those usual suspects that align together. But how we were 28 years down the road here, and we're still kind of talking about that being and we're a quarter of the way through the century, and we're still searching for the 21st century skills too. So I think those things would go a long way into getting us where we've tried to go for a generation of teaching now. I feel like I'm at that end of the of the line here.
So is what we've been talking about invention education, where students are making connections to real world problems? Or how do you define and explain invention education?
So, invention education is a student centered approach that equips students to solve problems they care about. The instructional approach responds to the needs of the problem solvers who draw on expertise from multiple disciplines, their cultural knowledge, and a diverse range of personal experiences to construct innovative solutions to real world challenges. In other words, it's STEM with a purpose. Students just aren't
Mm.
working on a project for a random reason or no actual reason at all. It's just not a class project at the end of the year after state testing that the kids just do for fun. Students are helping solve a relevant problem, something that matters to them and or their community. It's convergent learning. So students are not only able to understand why it's important to understand geometry, but they're also able to reinforce those mathematical concepts with science, language arts, fine arts, etc. All the subjects matter in their complementary pieces. And if teachers do this correctly, then the students are exposed to new skills and practices, and they're able to engage with tools and technology as they go through an iterative design process. Uh, you know, e- Even better, students will likely engage with adults in the field from higher education, local industry, nonprofits, government agencies that will expose them to mentoring, as well as an infinite number of other potential career paths. Again, it's all about having the students go through an experience. And it's just not an experience that the teacher dictates to the students, it's one that the student helps create.
Along the lines of doing that, aside from just the academic standards and the those types of things, but there's also a lot of soft skills involved with that. So kids learn how to talk to people, how to introduce themselves, how to their appearance, like things like that are important that aren't aren't in the standards book that are part of this that encourage. It's not, you're not teaching that stuff on as a standalone either. It's also ingrained in that with a purpose. And I had the pleasure, the honor, I guess, of talking to you and your team back on another podcast about 5 years ago when you guys were involved in a really cool project that was an MIT project. And I'm curious, how that the rest of the story if this were Paul Harvey. And so how did that turn out? And then how did that community focused and that real purpose driven and I'll let you introduce what the project was, um, how that turned out and if what where is that now? I'm just curious.
Yeah, so that project turned out to be amazing, and is actually the primary reason I'm here today. And not only that, it's also why I, as a teacher, have transitioned not only in roles to becoming, doing a different thing in education, but it's also a primary reason that I've become such an advocate for the invention education experience. I saw the impact that it had on my community, and I saw the impact it had on my students, and I want all kids to have this experience. So, just to kind of recap for everybody what happened, this is kind of a long story. So I was in the classroom for 27 years and was able to do some really amazing things. But the story that Matt just alluded to, our MIT, Lemelson MIT Invent Team, will always be my favorite story. I'll do my best to keep it short, but again, with something like this will be always my greatest accomplishment in education. And it was something that it was led by the students, and wonderful other staff members supported me. and our community, and it's everything that's good about education, and it makes me smile right now as I'm talking about it. So 5 years ago, as Matt said, I took 30 students on a field trip to the Air Force Institute of Technology, and we were learning about engineering. On the way back, I received an email from Lemelson MIT Foundation saying that I could apply for a $10,000 grant to fund an invention. So I told the kids this on the bus, and these were all high school students that just volunteered to go on this field trip with me. To my surprise, I had 14 students volunteer to work on this project with me. This was after hours on our own time. They just wanted to do something really fun and different. And, the opportunity to work with uh, MIT was also right, one of the main reasons. So as I went through, I started looking at this project and thinking about possibilities. So I asked other teachers in my building to work with me. And I also had 3 other science teachers as well as an English teacher that I was able to recruit. So you had 14 kids and 4 teachers that went together, and we had to draft a proposal. So our proposal, a problem that we found in our community, was that we have waterways from Mad River that just kind of go around and through our communities, and we were concerned about the matter with pollution because we all agreed that we
Mm.
wanted to do something that would benefit our community. And we went through and we submitted our proposal, and to our surprise, out of 14 schools across the United States, little old Greenon, little little public school, and that's in the middle of a cornfield, was one of 14 schools to be selected to receive this funding. And, I think just the
That's so cool.
outwelling yeah, right? It's the
Yeah.
outwelling of support from our community and the pride was just there. And, like, I think after we won it, all of us just the grant, all of us just kind of looked at each other like, "Oh, man." Like, we're in the Springfield News Sun, we're going through and, like, all the other kids and the teachers are talking about it. I have, so many other students that wanted to come up, be part of the project, but it's kind of like, we already have our team, so we have to go. So, um, it was just an amazing feeling. So at that point, as the program manager of this project, I we really we sat down as a team and we talked about, like, who do we need to get involved. So we asked Ohio Department of Transportation, Clark County Soil and Water, Clark County Engineers, other government agencies. They came in, met with the kids, and we talked about the problem and even took us a tour of our local waterways, as well as we learned all about the sewer system and outfall pipes and just like the trash that was being washed down the sewers. And that, like, one thing that surprised us is we thought, we were expecting that just like these are McDonald's cups getting washed down the sewer or just different other things. But we also learned that, like, in times when, like, after times of like high water and rain, that a lot of times just like raw sewage is flushed down the toilet out into our waterways, or that corn stalks were actually one of the major issues in our community of, like, things that clog up our waterways. So, like, it was amazing. And to, like Matt said earlier, like, my students were just talking to these wonderful adults that were volunteering their time. And this is like true education, right? They were learning how things work, and, like, how many adults really know how sewer systems work? But these kids, they were able to find out through talking with them.
Teachers, you can now earn contact hours toward grad credit for listening to the podcast.
Visit fortheloveofedtech.org for more information.
So, were your partners, I guess your community partners in that aspect that were offering their time, just employees at the water treatment plant?
No, so
Or
from all of the entities that I mentioned earlier were
uh
directly involved with this project, and they came into the school and they talked to us, and then they also took us out into the field so we could see firsthand what they were talking about. So we had our, like, little caravan of cars with just like
okay.
teenagers and adults, and just kind of, and even a school bus one time, and we just went all trouncing all around, just kind of learning what these people did and how things systems operated within our community. So after we went through and we kind of the lay of the land, literally, we went through and we wanted to learn more about fluid dynamics. So Greenan local schools, which is in Enum between Springfield and Fairborn, we really don't have a lot of industry, but we are very fortunate that CPEX is right off I-70 and they're an international pump company. So when we said we are interested in coming in and learning more about fluid dynamics, and we were interested in learning about pumps and drains, they rolled out the red carpet for us. They had snacks for us. They had all kinds of, like, they had like 10 employees. And not only did we get a tour, but they also taught us math, they taught us science, they taught us engineering, and we spent the whole day on site just learning about what they do and what we were dealing with and how we could measure all of the things that went on within the systems that we were going to try to like find a solution for. So after having a foundation understanding of the problem, as well as having a little bit about the necessary math, science, and engineering, we started to develop a prototype. So we divided our team into 3 design groups. One group would develop a large mesh sock that would capture collect the debris that came out of the outfall pipe. So when you're thinking about an outfall pipe on a sewer system, think of like The Simpsons, where you have like all the industrial sludge dumping out. Well, fortunately, we don't have that here. Like, it's, something, you have something on the end of that will catch any debris that came out of there. So we had one team doing that. We had one team that focused on designing the collars that would go around the outfall pipe. So these were like 2 metal rings that would attach with a tension sensor in between them that would hold the sock. And the third team had to come up with a way that those rings would interact with that sock so we could catch debris as it came out of the pipe, and then, but also not back up the drains, because while our community was very supportive of what we were doing, the last thing they wanted us to do was back up the drains and flood the streets.
Yeah. Probably a problem you'd like to avoid.
Right. Yeah, it's kind of like an ill-intended consequence, right? So,
Good job,
but
kids.
like one thing to prevent that was we had like a tension sensor on there, and I'll talk more about the tension sensor later. But the idea is when the sock got full, it would let us know so we could change it, and they thought it was a wonderful idea. So this is where like the community continued to shine. And because we went through and we're like, okay, we have this thing and we have grant money, but we don't have the technical expertise or the machines to actually build our first prototype. So that's when we went to Hayes Welding and Manufacturing, which is again right off I-70, and they helped us manufacture industrial rings that were used in our design. And then something that just kind of this warms my heart and is just a wonderful thing is we were looking for an industrial sewing machine, because we had this like high density like mesh that was made out of, think about like snow fencing, but think about, so like you have like plastic fencing but has very small holes in it, right? Because we wanted the water to flow through freely, but we wanted the debris to be caught in something that was durable. And so we needed to find an industrial sewing machine. So the Abilities Connection in Springfield, if you're not familiar with the Abilities Connection, it's a wonderful, they do a lot of things, but they also help sew cargo nets for the Air Force. And at the
Oh,
Abilities Connection, you have a lot of adults that have challenges, that part of their role is to work with people on site to fabricate things. So you had my students, many of whom are blessed in many different ways, and we were able to go on site, tour the facilities, and work with these beautiful people that are also blessed in so many ways. And they helped my students construct the mesh socks that were used in our design. So it was
oh,
just kind of one
cool.
of those things, when you see that, it's just kind of like, what a great life lesson and just what a beautiful thing.
Yeah, and the exposure.
Yeah, right. 100%. So after we had our prototypes, we had to make scale model prototypes, and we invited our community in for a mid-grant review. And when you come from a village of 2,000 people, as you could imagine, when your little town is getting involved with at the state level with government agencies, and you're working with MIT, like, a lot of attention. So we packed our whole cafeteria with people that just wanted to nerd out, and we're like wondering, what are you guys up to? And the best thing is the students presented, The students had like models, the students had studies. So the students went through and they drove the whole thing, and we had like 2 hours of just the students interacting with the public, with the adults. All we did was just kind of just like help grease the wheels and keep things moving. Um, and the big thing at the end of the night is we had told everybody in the room that we had the opportunity, we were invited to present at the Smithsonian Museum of American History in their Inventors Hall of Fame and on Capitol Hill in Washington, D.C.
Oh,
Everybody
wow.
went nuts. And as
That's crazy.
right, and like,
Yes.
and as any epic saga goes, you start off with all this excitement, but then you have the second act, right? Cue COVID.
Oh.
So we had all this momentum, all this public support, everything was just perfect. But then our project was effectively shut down and DC trip was canceled. So
Oh, no,
obviously,
you didn't even get to go?
no, no, it was like the biggest
Oh.
gut punch that you could ever have, because you literally had our whole entire community was rallied behind these kids. Like, while we had grant funding for like our project and to pay for supplies, we didn't have money to send 14 kids and 5 teachers to DC. So we had actually started raising money for that, and we even had like a local nonprofit, the Mud Run Conservancy. They donated like $4,500 just to like help fund us to go there, just because they appreciated what we were doing and they wanted the kids to be able to, have that experience. So it was just, everything just got shut down and we were just all so deflated.
Mm.
And then about 3 weeks after that, I received a telephone call from Tony Perry from Lemelson, MIT. And he's like, "You guys have an amazing project." He said, "Have you guys ever thought about applying for a US patent?" And I said, "Tony, we looked into it, but quite frankly, we're a poor rural school. We don't have the money to do it. So, we weren't even going to go down that route. We did talk to an attorney, and this being the coaches and the kids, but like we just didn't have tens of thousands of dollars to pay for the legal fees." And that's where Tony pointed out. He said, Tom, he said, 12 of your 14 students are female. And I'm like, I never really thought about it, because just these were the students that chose to work with me on this, right? And
Yeah.
and he pointed out that because there's so few females that go after patents, especially at younger ages, and he's talking primarily in college, but in high school to a lesser extent as well, that Microsoft had a pro bono program, and I believe they still do, called hashtag Makes What's Next, and their role is to support female inventors. So cue
Oh,
Microsoft.
cool.
Like, we're getting into the third act now.
Yeah.
Things are looking up, right? So
Yeah.
one of the coolest parts of this project was watching my students work directly with a team of 3 Microsoft patent attorneys to work through the patent process. I always remember the first call when the attorneys introduced themselves, and right away, it was cool because you had these, all of them were volunteering their time to support this, and Microsoft was supporting this as well, obviously. And right away, you had 2 female attorneys that were just strong and very smart and articulate, and they talked about the lack of representation of females in intellectual property and equity, and they started sharing tons of opening stats as well as their reason to do it. And you could just see everybody in the room, but especially my 12 girls who were equally just as driven and just amazing. You could see it had an impact.
I'm
Yeah,
curious,
yeah,
what
please.
where are these girls now?
So they're all over the place. So the
Okay.
cool thing is these girls are now seniors, and
Okay.
they've done just a wide variety of things. And like, some of them are engineers, a few specifically, that they do it. And there's a lot go. There are a few that went into medicine. There are a couple that went into the military. Um, there's one that she's now doing some computer coding. There's another one that's becoming a teacher. And then my son, who is also on the team, he became a welder. So
Oh,
it's interesting how
cool.
they just kind of all went different paths. Most of them STEM, not all of them, but like, there's even 2 that went into writing. Like, they're They're I think it's both are journalism.
Oh,
And one
wow.
of the cool things through this is, we totally took a team approach. So not only did we have the kids assigned to like a science cluster, or science engineering cluster, they were also designed to something like marketing, or they were they were going to be like help me keep the books, or they were assigned to publicity, or they were assigned to taking the lead on a lot of the logistics. So when it's again, when I say that this was kid driven, teacher supported, that is 100%. It wasn't the other way around. Then you have like the long wait, because just because you file for a patent doesn't mean that you're going to get it. After about a year and a half, we received word that our patent, we needed to just tweak a couple little things. And again, we met with our Microsoft advisors on what we could tweak, and we were able to just, it was the best day, and they made an
Hmm.
announcement in our school when we found out in the middle of the day that we were awarded a patent for our system for
Oh,
collecting debris.
awesome.
Oh,
Yeah,
so cool.
it was really just a crazy, wonderful thing to be involved with, and something that everybody was so proud of, and it was just wild.
Okay, well, so you talk about the sensors and so forth with the collection socks. So how did the technology play into this? The sensors and whatever else was involved.
Sure. Technology was an integral part of our invention education journey. One of the first things we were asked to do was do a public patent search. So, you can go to the United States Patent and Trademark Office website, and you can look and see who has similar inventions. Because again, you have to have a novel
Mm.
thing, right? It just can't be something that's already been done. Then the students use a wide variety of technology to build and test our small scale prototypes. Because one of the things, obviously, before we invested time and used resources to construct large scale things, we had to start small first. So we went through like the scientific engineering design process and went through and built small prototypes, which we tested first. And obviously, you have like all kinds of like vernier sensors and different other things to test flow and to test the strength of things as we were going through and manufacturing small scale versions of what our collection socks would look like. Our team used CAD to design the rings, and none of
Mm.
the kids knew how to use CAD because we just had like one or two 3D printers that the teachers mainly operated, but this was their project. So we all together learned how to use CAD to create these giant rings that would go along these outfall pipes. And I think a funny but very real story about our CAD design is, we went through and like we looked at the specs of the outfall pipe and how wide it needed to be, and just kind of like, these rings, we wanted them to fit close around to be snug, but also, we wanted them to be able to get on and off because they were going to be bolted, but we had to make them the right size. So when we sent, our team was very proud of the original CAD design that we sent to Mr. Hayes, and his email was like, he went over the materials that we wanted it made out of, and we were talking about it, and he's like, okay, he said, this looks great from a dimensions perspective, but are you aware that each of these rings are going to weigh over 1,000 pounds? Like, so like, then we had to go through, and like everybody just kind of started laughing because it's like, of course we didn't know that they would weigh that much with the materials we chose and the thickness. And like, so my students were able to go with him as a structural engineer and able to go through and like get those rings down to a tenth of the weight, right? So it's just kind of like practical engineering, and like you develop something that looks great in a CAD program, but in real life, it's just absurd. But it was a wonderful learning thing that we all laughed at. During our mid grant technical review, we use all kinds of sorts of technology to display data and to demonstrate virtual models of our prototype testing and what we are um, going to do in the field. So we had like mini stations set up with screens, which is really nice because the students had to create the online content that we could share in the room to, to put their words and put their thoughts into paper, into action, into graphic form.
Mm.
Um, and then, so just to kind of go back to like the whole invention as like a solution, a system. So the
Mhm.
way it worked is we had two rings. One was attached to the outfall pipe, which would serve as the anchor. The other ring would attach to the sock. so in between these two large metal rings, you had 5 sliding bolts. So what would happen, it would start off close together, and then it would pull as drag increased on the sock. Water would come out of the outfall pipe, it would push on the mesh of the sock, and it would cause a tension sensor that was mounted to the top to, like, the more it was pulled, the more the tension would read. So the more debris you had in the sock, the more the water would push on it and the tighter the tension sensor would pull. So when we said, okay, great, we have this tension sensor here. So what we did is the students came up with the idea, we wired it, and we soldered it to an Arduino board. And then that Arduino board, the students programmed the Arduino board that once the tension sensor reached a certain threshold, like there's this much tension on it, then it would transmit an RF signal that would be sent to a receiver that the students also built that would let the end user realize that the sock was full. Because part of our solution was to create something that could be used in suburban rural environments. So these were socks that couldn't be monitored 100% of the time, but still needed something on there to make sure when they got full, it would, like, ping the end user and say, "Hey, I'm full, come collect me." And I think the funniest story through the whole thing is, the kids could have just did like a normal beep or like an alarm sound that they transmitted into the receiver. But the student that I had, many of them were in band, and for whatever reason, they really liked 80s music. Keep in mind, this was just 5 years ago. So what they actually did is we had a sub team of the within our like formal teams that we had that translated a song from like sheet music to digital music notes.
Oh
And
my gosh.
the song that they chose, and keep in mind, they had to code each one of these notes, right? They had to code the pitch and the duration of each of these notes. So it was a very labor intensive process, but it was worth it to them because they got so much joy when anybody would pull the tension sensor and the song Africa by Toto would play on the receiver. So, like, maybe not practical if we were to sell this to anybody, but something that, like, again, it was their baby. They were loving it, and they spent so much
Uh,
time and they learned so much going through the process of coding that to, again, not only be transmitted, but also this is what happens when it receives a message.
just listening to this whole story, I can pick out lots of skills that your kids took away, but what would you say the skills that they gained were?
So the student, circling back to the beginning of our conversation, the students gained life skills. They gained
Mhm.
awareness. They designed a project that focused on their concerns. They interacted with adults in the field and were exposed to so many new careers. And one of the craziest things about the Invent Team adventure is that over the course of this project, I transitioned from being the student's teacher and conveyor of information to a project facilitator that just helped curate a series of interactive experiences. And my students were driving the learning the entire time. And all the other teachers that I did, we just became support mechanisms. We just became ones that would question the kids and push the kids and have the kids thoughtfully go through a design process. And it's something that all 5 of us from Greenland Local Schools will just always cherish. And obviously it was an amazing feeling and something I'll always be very proud of.
Yeah. I think you should be proud of yourselves. I mean, I know that you are, but wow, like what an endeavor and a cool opportunity for
Yeah,
you and the kids.
right. I don't know what I will ever be able to do to accomplish
Yeah.
something like this. It was just because again, it was just everything was great.
Mhm.
The kids volunteered, my peers, I'm like, guys, I got myself into this big jam. I'm going to need a lot of help, and they stepped up without question. The administration was so supportive. The community, like, I, I anything we wanted, like, we had to ask, and they would help us, and it was just what education could
Should
be
be.
and what it
Yeah.
Mhm.
should be.
Right.
Well, thank you so much for this conversation, Tom. We really appreciate it. Before we let you leave us, what kind of resources would you promote for teachers who maybe want to pursue this idea of invention education or any of the other topics that you've talked about?
All right, so a few things. One,
Hmm.
I would start with Limmelson MIT Invent Teams. They
Okay.
go through this every year, and their grants are up to $10,000. So if we can do it at Greenon, then I guarantee that you can do it too, especially when you have a broader community now that will help you, including myself. Secondly, I strongly encourage you to look at educational resources on the United States Patent and Trademark Office website, which we'll include with this podcast. Also, the United States Patent and Trademark Office has something called NSTI is a Summers Teachers Institute, where you have teachers come in all around the United States, and you get to like last year we were in DC for a week, and the USPTO pays for it. It's some of the best professional development you'll ever get, because you have people that have been through the patent process, like myself, with school kids. You have USPTO staff, patent attorneys, and people that read through patents to go through, and they talk about like what they can do and how they can help you. And you learn more about this invention education in general, as well as all the resources they have to offer. And then finally, Invent Ed. Invent Ed is a wonderful resource, and you can find it online, where they not only have USPTO resources, they not only have Lemelson MIT resources, but they have also so many other wonderful invention education opportunities that are housed and cataloged on their website, as well as just kind of all like, say, you walk to your administrator and you say, I want to do invention education. What is invention education? Invent Ed is a wonderful repository for all those kind of resources so that you could educate others to help you do something really cool for your students. And again, keep in mind, these aren't just special projects. Invention education is something that can be done in a regular classroom, in a regular school, while you're covering standards. It's just the kids care because they help drive the learning and you facilitate it in a different way. And it's just an amazing experience.
Thank you so much, Tom, and thank you, Matt, for hanging out.
Well, thank you so much for having me. It was a pleasure. And anything I can ever do to help in the future, please let me know.
Thank you so much for listening to this episode. We hope you found our discussion interesting and insightful. Don't forget to check out the show notes on our website, where you'll find more information about today's guest, resources we mentioned, and information on earning contact hours for listening.
If you enjoyed this episode, please subscribe, share it with your network, and check us out at fortheloveofedtech.org. This podcast is produced by SOIDA, the Southwestern Ohio Instructional Technology Association, in partnership with Think TV and CET, the local PBS stations in Dayton and Cincinnati. Until next time, keep exploring new ways to empower your students through tech, and we'll catch you in the next episode.